Hello everyone and welcome back to another video. In this tutorial, we are going to compile the Linux for TI SoCs. Till now, we use the AM335 board, which is a very basic SoC from the NXP, but this time we have a jump and we go for a TI SoCs. And for this session, I selected a starter kit from the TI, and it's running on AM335x, I believe. So let's get started. So as you can see, it has a 4.3-inch LCD, and on top of that, there is a resistive touch sensor as well. And on the other side, we can see that the base and the CPU, the main CPU, is a AM335 something, and it has a 256 megabyte of DDR3 RAM, and we have a input memory SD card. We have 2-port Ethernet, gigabit Ethernet. We have a USB, female USB-A. We have a debug port. They provided us USB micro, and it's connected to the FDDI chip and then connected to the UART0. So in this case, we have access to the debug port easily by the USB cable. And we have a power input. And I mean, in my board, I have a Wi-Fi module connected in here, but I mean, in this picture, it doesn't have. The same chip is used on the BeagleBone as well. So this is a well-known BeagleBone Black board. The same chip on here, but the BeagleBone Black has the HDMI output and eMMC, and obviously 512 megabyte of DDR3 RAM. But in our case, I'm just trying to use the LCD, which is more common in the industrial format. So I selected that board, but obviously we can run the HDMI output as well. If you remember from the Yocto project, what we need is some meta layer and also a BSP layer, a board support package. So in that case, when we feed this information to the Yocto project, it will easily compile the Linux for our target system. So you can search for a Arago project.org. So this project is maintained by a TI group, and it provides the distro and application layer for the TI SoCs. And we need the meta TI layer as well, because the BSP layer is included in meta TI layer. And we need meta Arago layer for the distro and application layer. So if you go down to this page, you have this Arago setup environment. Open up this one. And it provides some instruction how you can install and use the Arago meta layer. The first thing that we need is the cross-compiler tool. If you remember from the IMX board, we use the internal cross-compiler toolchain, but for the meta Arago layer, we have to use external cross-compiler toolchain. So in that case, we have to download the cross toolchain, as you can see, using wget address. But here it uses the GCC ARM version 8.3, but this version doesn't work for me, so I had to update the toolchain to a newer version. So in the Google, search for pre-built GCC ARM toolchain 9.2, and then go to this one. Okay, So this is the version that worked for me. So if your host system is Windows, you have to go for this one. But in our case, we are using the Linux host system, x86 64-bit architecture. And from here, you have to select ARch32 target with hard float, select the correct version and download it. Oh, wait a minute, I have to download it on my Linux system. So I just right click and copy the download link, go back to my host system, open up a new terminal, feed into the correct directory and use wget and download the file. Hit the enter. Okay, it's done. So the next step, right now we have .tar.xz file. We have to extract it and then put it into the correct folder. I use tar-jxvf, the folder name, and after that, I'm going to make an extraction on my home directory. So I just extracted. So you have to see all these files in here. So the bitbake uses these pre-built tool change to install all the libraries that we need for our target system. So the next step is to include the correct meta layers into our Pocky. So I can start from scratch instead of using my own Pocky folder. I can create a new folder, name it test Pocky, and download all the required meta layers in here. The first step is the cd desktop test Pocky. And first of all, we have to download the Yocto project. So what I can do is to use git clone -b to select the correct branch, downfall, and Pocky git repository. Hit enter. And after that, we will go to the Arago's project website. So it said that we need some tools to be installed in our host system. So easily just copy and paste everything in your terminal, your password. I already had all these libraries. It's okay. My current Linux system is 64-bit, but there is some libraries that are available in 32-bit format. So there's a trick for that. If you have a very old Linux distribution, you have to install this package. And when you have this IA32-lib package, you can install 32-bit packages in your 64-bit host system. But on the newer Ubuntu's, there's another trick. You can select the library and then colon and then I386. So in that case, the apt-get goes to the 32-bit versions of these libraries and install the 32-bits libraries. But before that, you have to do 32-bit architecture on, hit the enter. You can use update. And you have to use bash. Hit the enter, select no. And finally, you will be able to install these libraries. hit the enter. The next step is to download the correct meta layers. If we go to the Arago wiki page, according to the Arago project, you need meta TI layer, you need meta Arago layer. So let's start from the meta TI. So go down and select the correct repository, copy the link, go to your host system. So I'm going to download the meta layer. So I would recommend go to the Pocky folder, so which is here, and use git clone -b, and then select the correct branch, downfall, and the meta TI repository. Hit the enter. So the meta TI layer is here. The second one is meta Arago. Go to here, go down to the bottom, and you have to select the repository. Go back here, git clone -b downfill and the repository. So the next step is to add meta TI and meta Arago into our BB layer, which first we have to set up the environment. We use source OE. So it will set up the environment, the build directory will be here, local conf, BB layer. So we have to add those meta layers in here. But instead of manually adding them into the BB layer, let's use the code that we learned in the previous lecture. Bitbake -layers add -layer previous folder meta -ti. Hit the enter. Okay, it said that the meta TI layer is dependent on the meta ARM layer. So before adding the meta TI, we have to add the meta ARM layer as well. So if we manually just add everything into the BB layer, we didn't understand that. So good to use the bitbake layers and add layer. So it automatically detect the dependency and notify us. So how bitbake layer actually understand that there's a dependency in here? So if we go, for example, to the meta TI layer, go to the conf, go to the layer. So if we look at the layer dependence, so it said that meta TI layer is dependent at the core layer and meta ARM. So in that case, we know that this layer should be installed superior to that. And this layer is also compatible with the downfill because we use the -b to select the correct branch as well. So in the next step, we have to download the meta ARM layer. So how we will do that? Open up a Google and search for, openembedded.org. From the left-hand side, go down and select meta index. From the search layer, search your desired layer, meta-arm. You can see your layer here. So you can go to the repository from here. So it actually good. You will see that the meta-arm is dependent on the meta-arm toolchain, meta-python, and Openembedded core. So even before installing this repository, we need all these as well. So let's go and clone all of them: metaarm, meta Openembedded, meta Python, and metaarm toolchain. So let's start from the metaarm. Same as before, we go down, select the repository, copy the link, go back here, and let's open up a new terminal. It's better to go to the Pocky, same as before, git clone -b done fill, hit the enter. So metaarm is added. The next one would be Openembedded core. Copy the address. Same as before, git clone -b done fill Openembedded. Oops, I have to select the git one. Just check which one works for you. So the next step is adding the MetaPython, but the MetaPython is already in the Meta Openembedded. And the last one is the metaarm toolchain. And as you can see, metaarm toolchain is already available in the metaarm, so there's no need to download it separately. Okay, let's see what we get. Metaarm. So as you can see, metaarm toolchain is there. And you have to add all of them one by one. Clear. Add layer. So metaarm, meta-arm /. So these are the, you have to add each of them one by one. Meta-arm toolchain, hit the enter. So if there's any dependency, you have to make sure that the prior meta layer would be added before its dependency. Meta layer arm -bsp. So before that, I have to install the metaarm and meta Openembedded layer. So let's go back to the Openembedded and install the Openembedded layer. Meta open. Oops. Openembedded core. Hit enter. Okay, this one is done. I can add the metaarm layer this time, arm. So arm-bsp. So arm-bsp is Openembedded layer. Okay, I have to install OE as well. So go to the Openembedded org. From the left-hand side, layer index, OE. So I can select this one, copy, back here. git clone -b downfall repository. Okay, Openembedded should be here. So I have to add the desirable layer. So meta dash Openembedded. So what I need, first of all, I need the meta OE. Yeah. Let's check back. Meta BSP. So this time meta BSP is added. Metaarm. And here I added the metaarm. I added the BSP. I added the tool chain. Let's add the metaarm autonomy as well. Dash autonomy. But this one is related to the networking layer and visualization layer. So these two was on the Openembedded, not Openembedded core, but meta Openembedded. Networking and visualization. We don't have visualization here. So I have to install visualization in a different part. So I have to go meta Openembedded and then meta networking. Hit the enter. Oops, meta networking is dependent to the meta Python. So let's add meta Python first. Meta Python. And then meta networking. Oops, I have to add the visualization this time. Same as before, go to the Openembedded. Go to the layer index, search for meta-visualization. So meta visualization, copy this link and download the repository. So meta visualization should be here. Yes. I have to add it into my VB layer, meta visualization. Oh, Jesus. It's dependent on the file system as well. So let's find the file system layer. It should be on the meta Openembedded. Yep. Oh, Jesus. I mean, the very first time, it's really challenging to find all of them. But after, I mean, you have to do it only first time. Openembedded and meta-file system. Hit the enter. Okay. Let's see what we have. I added metaarm. I have to go meta TI. I have to add meta TI as well. Meta-TI, hit the enter. So hopefully all the dependencies are satisfied. Meta Arago. Oh, I have to add meta Arago as well. Meta Arago, and then I have to use meta distro. Okay, I have to add Qt5 layer as well and extra. So the extra is this one, but I have to add the Qt5 layer as well. Meta Qt5. Okay. Copy the repository come back and git clone that. Just make sure that you are selecting the correct branch. Okay. First, I have to add the meta qt5. Let's see if it has multiple layers. No, it's just one. Hit the enter. And after that, meta, first I have to use meta extra and then meta distro. So hopefully everything is good. Let's check the BB layer. Go to the build, go to the conf, go to the BB layer. So I think I have added all the layers that we need. I will come back if there's anything extra is needed. So the next step is to modify the local conf. Open up the local conf. So the machine should be changed. So let's see which machine we can use. Go to your Paki folder. Go to your meta TI, because this is the layer that provided the DSP for you. Go to the conf, go to the machines. And on here, this is all the machines that you can use. In my case, I have to use AM335x EMV. So I will use this machine. But as you can see, all the TI SoC products are here. You just select the correct version that is suitable for you. So on here, change the machine to the EMV. Okay. The download layer, SS8. The distro should be changed. So if you remember, we used Arago project to select the correct distro for our TI SoC. So in that case, we have to go to the Paki folder, but this time we have to go to the metaoracle distro, and here conf distro, and as you can see, we can use Arago distro in this file. I use Arago. Okay. The package class, I mean, for the Arago project, it is recommended to use package IPK. So make sure that you are using the IPK packaging. What else? So the last thing that you have to do is adding these external tool chains here. So if you're not assigning the tool change, the BitBag uses the internal tool chain, but it's not work for the Arago projects. You have to configure the external tool chain here. So you have to add tool chain underline pass is equal to, go to your home folder, I can copy the name, home Shahim, /home /Shahim. And the tool chain. Okay, I will go to the test Paki folder. I can open up a new tab. And you have to say bitbake. You can say core image base, core image minimal, but there's also another option. You can go to the Paki folder, go to the metaarago, meta distro, and you have to go recipe core, images, and you have access to all these recipes. So you can use TISDK base image, core bundle, default image. I use base image and bitbake, and then TISDK base image. If you hit the enter, it will start and downloading all the libraries and everything. But there is some tricky part. In my case, it doesn't succeed because some of these recipe, meta-TI and metaarm was not compatible with the meta-Arago because the meta-Arago was not compatible with these latest version of the metaarm and meta-TI. And I have found some of the compatible version of meta-TI. So it's a tricky part. Probably in the next video, I will show you a very straight path to set up Arago project. So in our case, we have to find a suitable version of the metaarm and meta-TI. So if we go to the, for example, meta-TI repository, you can go to the, for example, Dunful branch. As you can see, there's lots of different commits available on here, and some of them have special tags. I have found that, which is this one. Let me show you. I have to go a couple of pages back. 07.01.00.006 worked for me. But so I have to download this version. You can just download this one, hit the enter and download this version. Or in our case, I can select the tag name, go back to the Linux system, open a new terminal, and go to the meta-TI layer, cd meta-TI layer, and just I can use git checkout and the commit. So as you can see, the repository changed to this branch, this commit, metaarm. But this time, I will show you, go to the metaarm Dunful. There's a special commit that I will show you in a moment. You have to use git checkout. This is special commit. Hit enter and it will change. So everything is ready. And all you need is to say bitbake TISDK-base-image. Hit enter. So it said that metaarm BSP is dependent on meta-kernel. But wait a minute. There's no need to add this metaarm BSP because our BSP files is already available at meta-TI layer. So I just remove this one. Go to the build, go to the conf, look BB layer, and remove the metaarm BSP. Hit enter. Okay, it's parsing all the recipes. It gave you some error. Not warning because we are using the external GCC cross compiler. Just we will wait for a second to see if it go forward and without any problem. Okay, it's doing good. Yep, yes. So instead of waiting for a couple of hours to install all of them, I can use my own Pocky folder. So we can go through that one. Just let me halt this program. But everything looks good and working perfectly. So this is my main Pocky folder. I will open up a new terminal and say, first of all, I have to set up the environment. And I will use bitbake TISDK dash base dash image. Hit enter. I mean, I already have all the files in the Pocky folder, same as what I have shown you. And all the packages and meta layers on here. It takes a couple of seconds, I believe, because everything should be there in my folder. Just check out if all the files are good. Okay, so fast. Okay, it's created all the files for us. And yes, all succeed. I will go to the Pocky folder. I will go to the build. I will go to the temp external ARM library. I will go to the deploy images. This is all my images. As you can see, the device series are here. So we have a MLO file here, memory loader. And if you remember from the boot up process, I have shown you what is a memory loader, what is the U-boots, what is the Z image, U image. Okay. We have U-boots as well. We have environment. We have Z image as well. And also we have the VIC files in the .xz format. So what we need is to burn this VIC file into the SD card. So I just copy this file, go to the desktop, paste it on here. So the first step is to extract .xz file. So open up a new terminal, go to the desktop. I can use, instead of using tar, I can use on xz and then the xz file, hit the enter. So it just extracted that VIC file. So in the next step, I have to burn this VIC file into the SD card. So I will connect the SD card into my computer. The virtual machine, yes. I can show you the disk. The disk is a empty volume. So if you remember, we use sudo dd input file is equal to this file, output file should be equal to dev sdb in my case, and a couple of tags. ds is equal to 1 meg, I flag is equal to full block O flag is equal to direct, conv is equal to fsync, and status is equal to progress. My password. So I have to remove this extra slash and hit the enter. Okay, my SD card should be ready. I disconnected and then connected again. Okay, boot and root, both of them are here. So under the boot, it has MLO file, UImage, and environment. Under root, we have the rootfs. Under the boot, we have the device tree and the Z image as well. So it's ready for the experiment part. So in this step, I will go and install the SD card into my TI board. Let's just connect it, and I will show you a demo as well. So what I need is the power line and the micro USB to see the debug. So let's show you what is happening in here. So for the debugging, I need PuTTY. Go to the serial. In my case, COM9 115200. I have to hold on the power on button for 1 or 2 seconds. Okay. So it should be on my host. So it's here. COM9, open the port. Woohoo! It's working. And I can see something on the screen I can show you, but I have to stop the share screen. Oh, you can see that. Yeah, it's inverted. I mean, the camera is inverted, but I can see that it is straight. Yeah, it's working. It takes a while to start. Right now, I cannot show you both the board and my share screen at the same time, but I can see on the debugging port it is on, and I can log in into that. Let's go back to the share screen. Yeah, as you can see, it is logged into the device. I have to just use root. Yes, PWD. Yes, we are in the root folder. I can use uname -a as well. As you can see, it is. So as you can see, it is Linux 5.4, and it should be for 2022. So the UI is run up. I can go back to the UI as well. Let's just stop the sharing. Yes, I have the UI. So if I connect the keyboard from the top, I can type here as well. Let's show you a demo if we have time. Okay. There is a USB on the top. I just connect the USB. And I can type whatever I want. You can see that, but in the reverse. Hello. Okay, that's everything for today. Thank you very much for your watching.